Good day everyone. In this video, we are here again to present and demonstrate the AP13 motor fan. Before we start, here are the members of Group 2 Cyber Wizards. Josh Valerie Di Palercuna, Jan Cedric Lahato, Christian Barwado, and Ashik Alcinawa. What is motor fan in Arduino? In the motor fan, the Arduino controls a fan motor using a relay, which acts as a switch. The relay connects the motor to an external power source, allowing the Arduino to turn the fan on and off, based on specific conditions like temperature.
Here are the materials that we are going to use for this project. Arduino board. It acts as the microcontroller to control the flow of current and provide power to the LED. Breadboard. A platform used to build and test the circuit without soldering it. Jumper cables, used to connect different components on the breadboard or between the Arduino and the breadboard, allowing current to flow through the circuit. Button. It is a simple electric component that when pressed completes an electrical circuit. Relay. This relay can be used to isolate and control high power circuits such as fans or motors with a low power control signals like from a microcontroller pin. 220 resistor. Limits the current flowing through the LED to prevent it from burning out. Red 5mm LED. The light emitting diode that glows when electricity flows through it. Motor and fan. The small motor in the image is responsible for converting electrical energy into mechanical energy, causing the fan to rotate. Here are the added components that we are going to use for our challenge. One 220R resistor, one yellow 5mm LED, and two jumper cables.
Good day everyone. In this video, I'll talk about the instructions of how to assemble the AP13, and I'll explain step by step of how to bring down this circuit. First is the button switch. A push button is used here to control the fan. When pressed, it sends a signal to Arduino. Next is resistors. Two resistors marked as 220R are connected in series with the push button and LED. Next is relay module. The relay acts as an electronic switch when the Arduino sends a signal to relay module. Next, we proceed to our connection to Arduino. The push button is connected to a digital input pin 2 on the Arduino. The relay module is connected to another digital pin, allowing to Arduino to switch the relay on or off. And LED is also connected to show the status on and off of the relay. Next is the motor fan. The motor is connected through the relay, which controls its power. When the relay is activated by the Arduino, it completes the circuit, allowing the power to reach the motor's pin and fan blades. So, in our challenge in AP13, we added the yellow LED, resistor, and the wires. When the red LED
Hi everyone, in this video, I'm going to talk about how our code works in AP13. So first, the button pin 2, pin connected to the button in Arduino. Relay pin 3, pin connected to the relay. Relay state, current state of the relay starting as high or relay off. Button states hold the current reading from the button indicating if it's pressed or not. Last button state keeps the previous reading of the button so we can detect changes. Last debounce time records the time when the button was last pressed. Debounce delay, time delay 50 milliseconds to filter out button noise. Pin mode button pin input sets up the button pin as an input so the Arduino can read its state. Pin mode relay pin output sets the relay pin as an output so the Arduino can control it. Digital write relay pin relay state initialize the relay to the starting state which is high or off. Digital read button pin reads whether the button is currently pressed high or not low. It saves it in reading. Reading exclamation mark equal last button state if the current button state is different from the previous state. Last button state, it means the button has changed, press or released. Last debounce time equal millis. If a change is detected, it records the current time using millis. This starts the debounce process. Millis last debounce time. This checks the time since the last button change greater than the bounce delay. If this time is more than the bounce delay 50 milliseconds, it confirms that the button change is stable. The bounce so it won't react to rapid unintended presses. Reading exclamation mark equals button state. If the stable button state is different from button state, it updates button state equal high. When the button is pressed, it changed relay state to the opposite of its current state. Using exclamation relay state, if it was high, it becomes low and vice versa. This toggles the relay. Digital write relay pin relay states sets the relay pin to match relay states, either turning it on or off. Sets last button states to the current reading so the code can detect any future changes in the button states. That's all. Hi everyone, in this video, I'm going to talk about how our code works in AP13 challenge. So first, the in button pin equals to button connected to pin 2. Int relay pin relay connected to pin 3. Int relay state high. Initial relay states off. Int red states high. Initial LED states off. Int red pin equals 4. Red LED connected to pin 4. Int button state current state of the button. Int last red button state equals low. Last recorded state of the LED. Int last button states equals low. Last recorded state of the button. Long last debounce time equals 0. Last time the button states change. Long time debounce delay 50. Debounce delay in milliseconds. Pin mode configures button pin as input and relay pin and red pin as output. Digital write relay pin relay state and digital write red pin red state initialize both the relay and red LED to the initial high states or off. Digital red button pin reads the button current state and saves it in reading high if pressed, low if not. If the current reading is different from last button state, it means the button has changed, either press or release, so that the bounce timer is reset, using last debounce time equals millis. If the reading is different from the red state, this part update the debounce timer sets the LED pin to last red button state, and update red stain to the current reading. If the reading is different from last red button state, it resets the debounce timer writes the current red state to the red LED pin and updates last red button state to the current reading. Now, millis last debounce time greater than debounce delay checks if enough time has passed since the last button change. This helps prevent noise from triggering extra action if a stable state is detected. It updates button state if button state is high. Button press, the relay state is toggled. Digital write relay pin relay states writes the updated relay state to the relay pin, turning it on or off based on the last press. Last button state reading updates last button state with the current reading, preparing it for the next cycle to detect changes. That's all.